Okay. So, hello. It's great to be here again at ECC. I think I have been here almost every single ECC since the very beginning. So today I'm here actually with 5 of my kids. They're sitting in the back. We are traveling Europe in a camper. So we are just making a short stop here in Paris. So right now, maybe you know a bit of my history. I worked for Ethereum Foundation in 2014 and 15. Then we did Slockit and the DAO. I think everybody has been around for a while, has heard about the DAO. And now I'm doing Corpus Ventures, which is a venture builder. We are doing a lots of Ethereum and Web3 based projects together. I have my partner together today with me, Johannes Pfeffer. He is sitting here. And this is actually one of my favorite projects. It's called GasHawk. So what is GasHawk about? So the problem today is not as much as maybe last year, but those times will come again. How much gas did it cost to send an ETH transaction in 2021? And it was a lot. Today it's a bit less, but I think those times will come again. So the gas problem is still there. So if you look at some data, you see who's spending how much gas. There's a lot on OpenSea. There's just simple ETH transfers, of course, Uniswap, Tether, and some others. And a lot of them are actually not time critical. So if you look at the stars, those are just our suggestions about how time critical they are. Most of those transactions don't need to be in the very next block. They can actually wait for maybe 1 hour, some even a day or longer. And there's a lot of potential to save actually a lot of gas on Ethereum. So next problem actually, how much gas does it cost to deploy those smart contracts? So not too long ago, when I wanted to deploy a Gnosis safe, it would cost like $300 to $500, which is insane. And we always thought that smart contract wallets are the future, but that's the main reason why they kind of failed as the default for Ethereum users, because deploying a smart contract is just so expensive. So the solution would be, if all of those transactions could be automatically sent at the ideal time to save gas costs. That's the problem we want to solve, and that's the solution we have actually created. So let's look at something. We've just created a helper web page called should I send my transaction.info. So the bars are the base fee, and red just means we predicted to not send the transaction right now. So this is not in hindsight, this is like in real time. He's making a decision, is this now a good time or not? So if you're here, you don't know, should I send, should I not send, should I wait, do I have time to wait? So you don't really know. You don't know that that's actually the next couple of hours. And so what we see here is the green bars is when our algorithm predicted that now is a good time to send your transaction. And again, this is not in hindsight, this is like in real time, every time a block comes in, he makes the suggestion if the next block is a good or a bad time to send your transaction. So the prediction works pretty well. So then the question comes, I can just set a lower max fee and then just wait. So I can send a transaction. Let's take this as an example. You saw not too long ago it was 75 gigabyte as a base fee. Right now it's 100 gigabyte. I can just manually set 75 gigabyte in Metamask and then just wait. This usually works as well. You will be mined here. So it's okay. You have to manually do it, but it works. But you just have to guesstimate what's a good number. But you want to be mined here. And you don't want to make the guess, you want to make a smart guess or let someone else do the smart guess. And you also don't want to wait all the time. But how do we get this data? How do we make this prediction? So we did a lot of things, just some statistics. You can look at means and medians and some weekly limits and weekly medians and so on. But you can also do a Fourier analysis and see that there are actually very clear peaks at each week, each day, each hour, each half hour, and so on. Because there are bots and algorithms which are sending it exactly when the hour is over or when the day is over, or there's some things like this. And you usually have peaks in the base fee on exactly those times. So that's something you can predict. Then you can see when China wakes up or when the US wakes up, and you can see this very predictably. Also, you have this rubber band behavior of the base fee just based on EIP 1559. It's always like when it swings up, it swings down, and you can calculate actually a lot of it. Not all of it, of course, there is some which is just a prediction, but a lot of it is actually you can predict it pretty well if you have the time for it. So our algorithm was trained with all this data to give you like the best estimate. So this is what we used. So how do you use GasHawk? Right now, there are several ways of doing this, but let's start with the first one. It's a very simple Metamask integration. So actually, maybe let's go back one slide. You saw it. No, it was not here anymore. Okay, it comes another slide. So with Metamask, you can connect to our RPC proxy, and we are doing the waiting for you. So that's number one. We also have an application which is actually optional. You only use this app if you want to change the settings. So right now, as a default, we have set the waiting time for 1 hour. So if you just add us as a custom RPC provider to Metamask, then the transaction, we cannot change anything, of course. We get a signed transaction. We are just holding it back until we think it's now a good time to submit. And as a default, it's 1 hour waiting time. If you want to change the defaults and change the settings, you can also open our app. You can see the pending transaction and say I have 1 day or 1 week, so enough time to get even lower transaction fees. So we're also building currently an SDK, a Hardhat plugin, and a Foundry plugin. They are coming soon. With those, you can directly use them within your development environment. We're also building an API. So for example, for exchanges and others who are sending a lot of transactions many times a day, they can just use our API to save some transaction costs. GasHawk itself has actually just 2 components. The one is the RPC proxy, which just receives transactions based on an algorithm deciding when it's a good time to submit and submits them. And you have an application just for managing those transactions and changing settings. That's it. So it's actually very simple. So how you use it? Usually, Metamask and transactions. So now you have GasHawk in between. This is how it looks on Metamask. You just said, of course, GasHawk is not there yet to select it. You have to go in settings and add it as an RPC provider. Once you have done this, you can select GasHawk. So if you then have a non-time critical transaction, you choose GasHawk as RPC proxy and click send, and that's it. So it's still a pretty simple user experience, and you can save quite some gas. So what are the outcomes so far? So one of the employees, Steffen, he tried it out, and he actually had a 60% saving on using Arbitrum, so sending a transaction for only €8 instead of €21. And he didn't have to wait. We did the waiting for him. So we looked at this specific transaction. It was created at this point. Then a lot of base fee fluctuation happened, and then the algorithm decided to send it at this point. So almost the optimum. So of course, this was a bit lucky. Sometimes you don't get 60% savings. Sometimes you get a bit less. But if you extend the waiting period you're willing to wait, then it gets much better. So for which kind of transaction is this? So EIP 1559 is a great thing, but it optimizes for reliable submission in the next block. That's what it is for. Nice user experience, you can send and you're in. But it's not optimizing for low transaction costs. So there are things like ENS registrations, contract deployment, staking, voting, just sending ETH, auctions, lending, liquidity provision, approvals. Many of those things usually don't need to be within the very next block, but can wait a bit. Then there are some not urgent transactions, like all the badly designed stuff, some exchanges, arbitrage, MEV, minor extractable value, all those things, yes, they need to be in right now. That's different. There you don't need GasHawk. But actually, a majority of the transactions can wait. So as a takeaway, GasHawk is for non-time critical transactions. So currently, the data suggests you will have an average saving of about 30%. So you can think of it as a load balancer for block space demand. So Ethereum basically is not equally loaded. There are high demand, low demand, high demand, low demand. So if a lot of people would use GasHawk, this would eventually lead to a very smooth base fee. So then, of course, the savings would go down, yes, but there is still a lot of savings in there in the current big fluctuation of the base fee. It right now works on Ethereum mainnet, and the beta will be open for users by 1st of September. So if you want to use it, just go on Twitter and send us a direct message, and we can add you to the list. And then very soon it will be open for everyone. And you can use it within your application through the API or the SDK. And you can use it for yourself just by using Metamask. And it's still millions of dollars per day, which is still being paid for transaction costs. And if you can only let's say 50% of this is non-time critical, and then you save roughly 30% on this, you can calculate how much gas savings there actually is, how much opportunity there is for gas savings on Ethereum. Okay, that's it. So do you have any questions? Yeah.
So with the RPC that you add to your MetaMask, when you send your transaction, do you select a gas amount and then you determine an amount lower than that? Or like how do you limit the max that you would spend for your transaction?
So basically you only have to select the lower base fee, right? And then you still have the max fee. And then it's only for us to decide when to actually send it. And you only pay the base fee based on the block that's actually getting sent. Of course, if the max fee is too low, we cannot send it. Yeah. Johannes, do you want to add anything? Maybe you can just come in front. Johannes is the one who actually built most of it and was part of this. So even I get to talk here. He's the one doing it. So.
Yeah, I would add just one thing to the answer of this question.
Because then the registry can see.
Actually, you could even set a very, very high base fee and a little bit higher priority fee. Maybe not go for 1.5, but you would go for 3 or 4. So when the algorithm decides that the transaction should be submitted, it will remain in the mempool for only a very short time and will be picked up right at the correct time. If you have a low base fee, it could happen that at that time you're actually lower than the current requirement of that block. So yeah, high, but you can usually just leave the fee that MetaMask is put it on high priority. The high priority in this case doesn't mean it will be higher priority, it just means it has a higher base level of the fee and you have a big chance to get in at the right point.
So often when I'm making transactions that are not urgent, they are not urgent, but you do have to make like 3 transactions in a row. So how do you solve that? Like, let's say like you approve one token and approve another token, then you want to submit a transaction. How do you solve that?
So yeah, this gets tricky sometimes, especially when transactions depend on each other. So if the output of one transaction goes as input of the next transaction, in that case you actually would have to wait until the first transaction is mined. You would, in GasHawk, you would then set maybe a 10-minute time limit, whatever you can afford to wait, and then use the output of that transaction as an input. All transactions on Ethereum are ordered, so we will execute always in the order of the nonce, of course. We just get signed transactions, and we have to execute them in that order. But there's one advantage you actually have, because GasHawk caches the transactions. You have something new, and that's a transaction manager. You have signed transactions that are queued for being mined at some point when the price is low. And if you later decide that one of these transactions should go, you would just delete them from the queue. If it's in the middle of the queue, you would have to re-sign the other transactions to make the nonces work. But you have an additional area where you can manage your transactions before they actually get mined. So there are some UX quirks when they depend on each other, but there's also advantages. It's just a new paradigm of thinking about transaction handling.
Yeah, there was a question.
There's one more question, I think, or maybe 2.
Hi. So quick question, like which entity is actually executing the transactions in the end? Like, is it your team? Is it like relayers outside? Like,
yeah.
Can you like describe a bit more? Like,
of course. So
the execution in the end.
So what the RPC proxy, what the RPC endpoint you set in MetaMask actually does is it's a proxy. You can think of it as a proxy. It takes the transaction and it just does not forward it to the mempool. And forwarding to the mempool, in case of MetaMask, means sending to Infura. So for now, we are using the same endpoint as MetaMask. Once our algorithm decides to send your transaction, we will just give it to Infura, just like MetaMask would do. But you could also set the RPC endpoint of Flashbots or your custom one. It's not yet built in, but there is no reason why you would not be able to decide yourself what endpoint, like what way of sending the transaction. You could even use your own. Right? Just use the signal of GasHawk for the time when you should send, and then it will just submit to your own RPC endpoint. That's possible. Right now, the default is the same as MetaMask, so it will just send to Infura once the time has come.
All right, thank you.
Okay. One more question or no? There was one more hand. Last question.
Hello, thank you for the presentation. As far as I know, in your wallet, you have to execute the transactions in line, like when you have waiting several transactions. How are you working with that when you're trying to time them?
I think this was the first response. Most importantly, you have a nonce for each transaction, so you cannot really have a wrong order on chain, since you have signed on different nonces, right?
Yeah, and actually that is one of the points where there can be still optimization. Right now, they will just be executed in order, in the same order you sign them, because that's the only order they will get mined and not be rejected. But if there are several transactions and they all have the same type of deadline, let's say you always use the default of 1 hour, they can also be a package of consecutive nonces can be submitted at the same time. So let's say you have 5 transactions in our waiting list. They have nonce 1, 2, 3, 4, 5, and they all have a similar deadline and should be mined within 1 hour. That's what you set in GasHawk. Then once the time has come and the green area is reached, which is the best time we predict for the next hour, then all of them get sent at once, and all of them will be mined in that block. If they have different timelines, like you have one transaction that can wait 1 hour and one transaction that can wait 1 day, yeah, then those times add up.
So thank you very much for your attention.